Hey Valley Kids, let's do this chapter review here. The first one, write the following powers as product of the same factor. Let's take this word power out and let's write the word exponents. That's another way of saying it. Write the following exponents as products of the same factor. What that means is you take 5 times 5 times 5 times 5 times 5 for this one. The exponent, it's 5. That's what the base is, and the exponent is 5. So it just means there's 5 5s, and you multiply them all together. There we go. 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. I get confused saying them all, so I'll just count them. I've got 5 of them, and I got multiplication signs in. That's all you have to do. For this one here, our base is 3, and our exponent is 4. There are 4 of them. So 3 times 3 times 3 times 3. I've got 4 of them. That's what it means right there. All right, this next one, we're just going to reverse it. Now we're going to write an exponential form. So 7 times 7 becomes, we have 7, and there are 2 of them. The exponent tells you how many there are. Just like up here, our exponent was 5. There were 5 5s. Over here, it's going to be 9, and it's to the 4th. There are 4 of them. All right, now we have to actually put this in, and we have to solve it. And I got to grab my calculator here, because I will need that. So this first one, it's 2 to the 4th. I can do this one. It's 2 times 2 times 2 times 2. Just like in this first target, that's how we put it into the calculator. So this would be 4. This would be 4. 4 times 4 is going to equal 16. 2 to the 4th is 16. This one here, I'm going to use my calculator on it. 6 times 6 times 6, right? So let's just pop it into the calculator. 6 times 6 times 6. 216. That's what that is equal to. Remember, the word evaluate means to solve. All right, this next one here, I'm going to move this over. This is a big order of operations problem, and we're going to need some space. So I'm just going to carve out a little space over here. And let's put that in. I'm going to slide my paper to. You know what? I need to redo this here. Let's get this a little bit larger for you. See if I can drag this out. I can't. We're going to have to work there. I can do this. All right, we have 10 plus 10, and we'll put that in parentheses, and that's divided by 2. That's times 3 minus 3 squared. All right, step by step. Here's PEMDAS, P, E, M, D, A, S. Remember, multiplication and division, those come in the order in which they arrive, right to left. First come, first serve. So we have to do the parentheses first. So this is 20 divided by 2 times 3 minus 3 squared. Now I just make one change. Now I have to do my exponents. So let's check. There's the exponent right here. So that's 3 times 3. So that's 9. So I'll rewrite everything. 20 divided by 2 times 3 minus 9. Okay. So now I've got division, multiplication. It says multiplication, division, but remember this is first come, first served. The division comes first. So I'll do this. 20 divided by 2 is 10 times 3 minus 9. And now I have to do the multiplication. So that's 30 minus 9 equals 21. 21 for that example there. Just slide that over so you can take a quick peek at it. All right, now we're going to do the same thing with this guy here. And let's just take and carve out a little bit more space here. Make a nice little area right here. So now we've got 7 squared minus 12 divided by 4 plus 12. Let me just make sure I have the problem right. 7 squared minus 12 divided by 4 plus 12. All right, well, there are no parentheses, but we do have an exponent right here. So I have to start with my exponent. So that's 49, that's 7 times 7, minus 12 divided by 4 plus 12. Now, I've got subtraction, division, and addition. Division comes first on the PEMDAS order. So rewrite everything. 49 minus, now 12 divided by 4 is 3, plus 12. All right. Double check. I did my exponent, and I did my division. Now I have subtraction and addition. So I'm just going to go ahead and subtract. 49 minus 3 is 46, plus 12. All right, 46 plus 12, and you can use a calculator on this one too, is 58. There's my answer for the second one, it's 58. All right, let's slide this back over and get to number 1. That was 1.4a. I did those two. We'll do 1.6a. Let's just go ahead and slide up here so we got some more work room here. And 1.4a, 1.6a, number 9. We'll look at that. All right, number 9. M plus 5 when M is 30. Well, that just means you take 30 and you put it in for M. That's all it is. You're substituting it. So you have 30 plus 5 equals 35. You got to get those ones right, kids. Those are so simple. That's a 35. Let me rewrite that 35. 35. All right. Now this one here, 8s when s is 12. So now I got 8 times s. Well, s is 12, so I'm going to write 8 times 12. And if I pop that into my calculator, that will equal 96. Okay? All right. Now 1.78. This one's going to be tough. Bill washed 7 cars last Sunday. I'm going to write down the number 7. He charged the same amount in for each car he washed. He earned a total of $84. So I know he's going to equal $84. So, and I know I have to use n somehow. So it's 7, let's see, 7 times n equals 84. Let's see if I can tell a story. He washed 7 cars. He charged a certain dollar amount for each car, and he got $84 in total. So 7 times the dollar amount equals 84. A math geek would probably write 7n equals 84. All right, the next one. Jack worked 4.5 hours on Monday. So Monday, 4.5. 6.5 on Tuesdays. Let's go Tuesday, 6.5. And on Wednesday, we don't know. He worked H. We'll just put H for hours. He worked a total of 16 hours. So I bet you that's going to be equaling 16. So let's see, what could I do there? I know, I'll just put addition signs in there. 4.5 plus 6.5 plus h equals 16. Now remember, all we had to do was to write the one variable equation. We didn't need to solve them. That's why I just left it. Here's the equation I wrote. Here's your answer right here. I'll rewrite it. 4.5 plus 6.5 plus h equals 16. If you wanted to, you could add these two together as well. All right? Either way works great. All right, well, let's slide this guy over a little bit and do the rest of the problems down here on this page. All right, so we have f plus 6 equals 11, and we just have to solve them mentally. I think that means something plus 6 equals 11. Now, I happen to know that it's 5 plus 6 equals 11. That's my answer. But if I didn't, I could just take 11 minus 6 and get 5. That would work. So now I have 5 times something equals 30. 5 times something. 5 times 6 equals 30. And again, it's multiplication, so I could undo that by saying 30 divided by 5 equals 6. That would work too. All right. Now I have to rewrite using the distributive property. So here I have one set of parentheses. I know I've got to get this down to 2 sets of parentheses. So I'm going to get my arrows. That first arrow says I have to do 3 times 5. So I'm going to do 3 times 5. And then the second arrow says I have to do 3 times 2. So that's 3 times 2. I've passed out or distributed that 3. This plus sign comes right down in the middle. It just says that 3 times 5 plus 2 is the same as 3 times 5 plus 3 times 2. So here's the distributive property backwards. Now I have 2 sets of parentheses. I'm going to go down to 1 set of parentheses, and one thing will go in front there. So I see that I have 8 for both of these numbers. So I'm going to put an 8 here. We'll put my 5 here and my 3 here, and I'll move that subtraction sign down. So if I want to double check this, I'll just see, can I use my arrows? Do I have 8 times 5? Yeah, here's 8 times 5, and there's 8 times 5. Do I have 8 times 3? Yep, here's 8 times 3, and here's 8 times 3. Am I subtracting? I am. I have rewritten that problem. All right, now, Commutative property. Crazy Mrs. Carruthers commutes. That means to go back and forth. Remember, 1 plus 2 plus 3. The commutative power says that's the same as 3 plus 1 plus 2. See how I moved that 3 over to the front? That's the commutative property. So I'm just going to say that I've got 5 times 28. Now I can't move the brackets. I can only move the number. So I'm just going to move this 20 over to here. 20 times 5 times 28. These are dots. These are multiplication. I'm starting to sound a little bit like Sal Khan. Okay, boys and girls, we are going to use the commutative property to rewrite this one. Let's see now. We have 74 plus 13 plus 16. So I'm going to commute this number over to this side here. I'm going to move the number but leave the bracket. So we have 13. Let's see, 13 plus 16. And I will add the 74. I've simply moved the 74. I've commuted it. That's a very bad imitation of Sal Khan on Khan Academy. He's a pretty cool dude, man. I learned a lot watching his videos. All right. You just have to move the number, but you can't move the brackets. That would be two properties. This property, we move the brackets, the associative property. So now I've got 5 times 20 times 7. So this is where my brackets were before. I got to keep the numbers the same for the associative property, but just move the brackets. So I just put the brackets here. 5 times 20 first, then times 7. Here, 8 plus 14 plus 6. The brackets are over here. I just move the brackets. The associative property. You just move the brackets. All right. Let's keep rolling here. We have to evaluate some things. Now, I know that if I gave you a calculator, you could solve these problems. And that's all I'm asking you to do. Evaluate simply means solve. You could put in 14 times 5 times 2 into the calculator, and it would work. And you would get the answer. I'm just going to do this first, because then I don't need a calculator. I can do that. I can group this way. 5 times 2 is 10. 14 times 10 equals 140. I want to prove something to you. I use the associative property there, but it doesn't matter. You can just take 14 times 5 times, oops, let me redo that. 14 times, nice duds, 14 times 5 times 2. It's 140, it's the same thing. It's multiplication. Just use your calculator on 1.8D and solve those problems. These ones here, I want to group this and this, because together they equal 100. 100 plus 29 equals 129. But I can just put them into the calculator too. I can just say 86 plus 29 plus 14 equals 129. It's okay. Either way works. All right. Write an equation using two variables to represent the function the function in each table. All right, so we're going from 1 to 4, and we're going from 3 to 8, and we're going from 2 to 8, 3 to 12. It looks like there's a difference of 4 here. Each time it goes up by 4. Now the Wooten Tootin' Cowboy would say that if it goes up by 4 like that, it's 4 times something. So let's just see if 4 times it works. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. That's it. So this is my x and this is my y, right? So my y is equal to 4 times whatever the x is. And there's your little equation right there. Y equals 4x. So on this next table, let me slide up here a little bit. On this next table, we got to figure this out too. So now we got 1 is going to 3, 2 is to 5, 3 is to 7. Uh-oh, it looks like it's going up by 2. 5 to 7. So I'm thinking that this is 9. And that would have to be 11, and this would have to be 13. Let's see. 1 plus 2 is 3. 2 plus, 1 plus 2 is 2. Oh boy, it didn't work, did it? Oh, it must be times 2. Remember Mrs. Wooten's thing is she said when This difference is 2 over here, and it's consistent. It means that it's times 2. Remember up here, it was the difference was 4, and it was 4 times. So we're thinking that it is times 2 something. So let's just try this. Let's put in, we've got y equals 2 times something. Now remember, there might be a minus or a plus on there. We're not sure. So let's put in 1 times 2 equals 2. Boy, I got to add 1 to it to make it work. So let me try. It's 2 times something plus 1. Let's try that. 2 times 2 equals 4 plus 1 is 5. Oh boy, let me try this one now. 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Oh boy, it's working. So our little formula here is it's y is equal to whatever 2 is, the 2 the x plus the 1. All right. So remember, when you're looking at the difference here and it is consistent, that doesn't mean plus 2. It means it's going to be times 2. This difference was 4. When the difference is 4, it's times 4. But the catch is, these numbers over here have to be in order. You can't be skipping any numbers. So 1, 2, 3, 4, yep, 4, 4, 4, 4. 1, 2, 3, 4, 2, 2, 2, 2. If any numbers are skipped over here, then that won't work. All right, so we got y equals 2x plus 1. All right, this one here. Identify the domain and range for the table above. All right, well, here's my domain right here. So I'm going to write domain is equal to, and I'm going to put it in parentheses, I've got a 1, I've got a 2. They're just the x values. I've got a 3, I've got a 4, I've got a 5, and I've got a 7. Now the range is going to be equal to the 3. They're all the y values. Now I had to fill some in here, remember? I'm going to double check here. Just make sure this works. 2 times 7. Uh-oh, that didn't work. 2 times 7. Uh-oh, I skipped one here. That's not a 13. Look, it's 1, 4, 5, and then 7. 2 times 7 is 15 plus 1. This is 16. Boy, I got to watch out. I almost missed a value there. So 5 times 2 plus 1. 5 times 2, that's 11. 4 times 2 plus 1 is 9. Good. Just double checking. I almost had a wrong value there because it didn't go consistently. All right, so I have my x values or my ranges are 3, it's 5, it's 7, it's 9, it's 11, and it's 16. All right, 1.10b1. I can write a two-variable equation to represent a function. Let's slide this up so you can see the domain and the range. All right, and actually this is 1.10b2. This is B2, and this is actually B1 up here, where you write these ones here are 1.10B1 if you want to watch that video for these two here. That's 1.10B1 when you take a table and you write an equation. 1.10B2 is where you have to write a word problem or take a word problem and do it. So I'm going to have to make this a little bit smaller to get the whole word problem in. So we'll take a look here. Got to go even smaller. Sorry, folks. Technical difficulties. All right. So Ray downloads iTunes songs every week. So he downloads some songs. Each song costs $1.55. So the cost is $1.55. His total cost is C dollars. Cost is C dollars. All right, I don't even know where to start here. Write an equation to show the relationship between S songs and the total cost. Well, if I don't know where to start, I just make a table. Now think about it. What if it was a one song? Well, one song would cost $1.55, right? 2 songs would cost, well, wouldn't that be $3.10? Let's just pop that in and make sure I'm adding right. 1.55 times 2 Yeah, $3.10. So 3 is going to be 1.55 times 3, $4.65, and so on. So I've got an XY chart here. This is an X and this is a Y, but I've got to put these other things in. So X is really the songs, or the S. These are the songs. This one here, this Y is really the D, or the dollars. So if I had to rewrite this, I could say, first of all, I could say that the Y is equal to whatever the X is times $1.55. Or I can write it like this. I can use their letters. I can say that the D, the dollars, will be equal to whatever the number of songs is times $1.55. 1.55. Or you can write this D equals S 1.55, and you could pick and put some parentheses here if you'd like to show that that's multiplication. However you want. That is your answer. Okay? The dollars, the total dollars will, sorry, it's actually not the dollars, but the cost. Sorry about that. The cost is equal to the songs times 155. The cost equals S times 1.55. I'm sorry, it's a rough video. I just had to sit down and run through it real quickly. Didn't have time to make a second one. Now you know how long it takes me to make one of those ones that's perfect. It takes me about 20 tries. Thanks for listening. Hope this helps. Bye.